How do we get kids excited about programming? Make programming tangible with embedded devices. Did you know that after kids learned to code with a BBC microbit, 90% of them thought that coding was for everyone, and 86% said it made CS topics more interesting? One person doing great work in this space is Nina Zakharenko. She's here to tell us all about her projects with CircuitPython. This is Talk Python to Me, episode 221, recorded June 24th, 2019. Welcome to Talk Python to Me, a weekly podcast on Python, the language, the libraries, the ecosystem, and the personalities. This is your host, Michael Kennedy. Follow me on Twitter where I'm at mkennedy. Keep up with the show and listen to past episodes at talkpython.fm, and follow the show on Twitter via @talkpython. Hey everyone, before we get to the interview, I want to quickly tell you about a new course we just launched. It's our first major Flask course, and it's called Building Data-Driven Web Apps in Flask and SQL Alchemy. This one's a deep dive into Flask. We cover things like routing, models, templates, databases and migrations, and even deployment and security. And we do all of this in the context of building a clone of the pypi.org website. Check it out over at training.talkpython.fm. If you're not sure if you want to choose Flask just yet for your web app, then give our 100 Days of Web course a look. We cover many frameworks and programming models in 25 4-day projects, so you get a super wide view of what's out there. Then you could pick Flask or Django or Pyramid or something else. Thanks for checking it out. Now let's get to the interview. Nina, welcome to Talk Python.
Hi, thanks for having me.
It's great to have you here. You've been on Python Bytes, but not Talk Python before, so I'm really excited to talk about some of the really cool stuff you did at PyCon, at some of these other Python conferences, with hardware and embedded Python and a lot of cool stuff you're doing.
I'm really glad to be here, and we're recording a special episode from Portland from my home office.
That's right. Yeah, we both live in Portland, so doing it live, it's going to be great. So before we get into embedded Python and CircuitPython and all these sorts of things, let's just start with your story. How did you get into programming in Python?
It's a little bit of an embarrassing story, how I got involved in programming in the first place. I was lucky to develop an interest from a young age. So when I was about 11 or 12, I found out about the band Hanson. You remember that?
Yes, I remember Hanson, the boy band, right?
Yes, and I really didn't like them, and I wanted everyone else to know. And so I figured out HTML and figured out how to put up a GeoCities site. So I could, put some stuff on there, some animated GIFs.
GeoCities, like people might not even remember GeoCities, right? those were early days. Like if you just had a website, people were impressed. It didn't matter what it was.
Yeah, it was like kind of like free, single page web hosting. And I think it really kind of changed the landscape of the internet, right? It made programming, even simple things like HTML, something that was accessible to a lot more people.
For sure. So you had this thing against Hanson.
Yeah.
All right. How'd that get you to programming?
There weren't really a ton of good resources out there. There wasn't, GitHub where you can just go and look at somebody else's source code. And so I just started out by right-click, view source pages that I liked and figuring out how they did it. And then, figuring out how HTML was structured and all of that. And that kind of started my curiosity. So I did go a more traditional route and went to school for computer science, and I've been in engineering ever since.
Yeah, that's really awesome. So how'd you get into Python from there? Because GeoCities and HTML and ViewSource, that's all just the web front-end stuff.
There was some period in my life where I called myself a full-stack developer, but I was always, that half-drawn horse full-stack developer.
Yeah?
Yeah, where I just naturally gravitated more towards back-end programming than front-end. So I learned Java in school, and then I did enterprise Java for a really long time and worked on some really boring software.
Yeah, a lot of forms over data and data entry and all that kind of stuff.
Financial software. I worked on software for satellite control computers when I worked at HBO. And I didn't really kind of lost touch with software being fun, or software kind of having creative purposes. I would just go to work and feel drained. I didn't really know much about open source or the open source community. And at one of my jobs, I was doing my enterprise Java thing, and we had started using Python for a little bit of scripting and for the API. And so I started dabbling in that. Had the opportunity to go to PyCon. So my first PyCon was 7 years ago. And I was just kind of dreading it. I was like, I'm going to be a noob in this thing and I'm going to get made fun of, or people are going to call me out. And it's going to be so horrible. And then I showed up and I was just overwhelmed with how friendly the community was.
Yeah, I had the same experience, just when I was getting into Python, I thought, it was rough. And you said you came from Java, like I came from C# and I was really good at it. And I'm like, I'm going back to being like a true beginner, where I'm just going to make all these stupid mistakes. And, people were super supportive and friendly. And I really thought it was a special place, right? It just made me want to get into it even more and so on.
Yeah, I came back from my first PyCon and I was like, how do I do this more? Because people were, they weren't just kind of friendly to me and welcoming to me. They were really generous with their time as well. So one of the first sprint projects that I worked on, someone that I had met who was an engineer at Google, instead of sprinting on a big fancy open source project, just sat with me and helped me talk through some of the issues I was having with my own code. And I was I was floored, right?
Yeah. Why is this person who's like such a high-end developer messing with my stuff, right?
Yeah, but they were so, happy to do it.
Yeah, that's awesome. That's definitely kind of epitomizes what the Python community is like and why so many people stay and love to work there.
And I try to pay it forward,
Absolutely. And I definitely do think you do. And it's worth pointing out that you gave the closing, was it the closing keynote
at
PyCon?
Yeah.
Yeah. So you were basically, you stressed out the whole PyCon.
Yes.
Because at least for me, like we were talking earlier, like it's hard to relax if you're giving conference presentations and stuff until they're over. And, if yours the last one, you got to just like hold your breath all PyCon. But it was a great presentation. You talked about some really cool ideas about making programming fun again and personal and maybe creative and not necessarily just for closing Jira tickets or whatever, right? So nothing wrong with that. Like it's great to do programming as work and a lot of times it is fun, but a lot of us have jobs where it's not exactly the reason we got into programming, right? So it's cool to do really useful stuff or really playful stuff, I guess, rather not useful stuff, maybe even. And so one of the themes of your talk that I wanted to start off with and discuss with you is you said like software doesn't have to be serious. What's the story of that?
Not a lot of people know this about me, but now they will. When I was in high school, I was just totally goth, just had dyed black hair. I had a lot of piercings. And when I graduated college, I was like, nobody is going to give me a job if I look like this.
Yeah. I can't work at IBM. Like, where's the formal dress code of this place is not going to mesh with me, right?
Yeah.
Yeah. Okay.
I didn't know anything about startups. I didn't even really know anything about how to go out and get a job after I got my degree. And so I just kind of toned it down and also got a really dry job in the financial sector because they were the first ones to take me out to a nice dinner. And I was like, whoa. So I just kind of fell into it without really knowing what I was getting myself into. And I just, I didn't have kind of the time or the energy really to do a lot of coding on the weekends or do a lot of coding after work. And it wasn't until I found areas that I was kind of really passionate about for other reasons, not just tutorials or quizzes or whatever, that I started spending a lot more time on it and kind of getting really interested.
Right. The stuff you do in the financial place is not a super fun thing to take home and work on, right?
Yeah.
So you got to find something else. Yeah, that's cool.
So I showed you, this headdress, this LED kind of headdress that I built with, flowers, and it's really beautiful. And I worked on that for hours, just
for this whole show, everyone. I'm going to basically have to be like the narrator since a lot of this stuff has a visual component to it, right? Like it's, you push this button or we plug in this device and what does it look like? How big is it? So I guess I'll start by describing the headdress. It's like I don't know, it's probably like a big circular fan type headdress, and it's probably fans out about a foot or so. And it's got all these LEDs that are going. It's super cool. And so that you built with Arduino, right?
That's right. So that does not run Python. I use something called the Fast LED library.
Yeah, and that was just about really just animating LEDs, right? And so there's kind of it's actually a big thing and it's pretty omnipresent, right? It would definitely stand out at a party, but it's not a huge programming thing, right? It's not like super interactive in that sense, right?
It's not interactive, but there is a push button. So there's 6 or 7 patterns that I programmed.
Okay, yeah. So there's some interactivity to it. Okay, awesome. All right, so you did that and you're like, hey, this embedded stuff, this is pretty cool, sort of designing things with Python. And that's definitely got to be a lot easier these days, right? There's a lot more stuff out there, a lot more little boards and devices you can get, right?
Yeah, this field is, at least for Python, is still very, very new. So all the software, all the devices, there's a lot of excitement in that space and things are kind of moving pretty quickly.
For sure. So I guess maybe the headdress you described maybe falls under art. There's also animations, but like actual graphical animations people could play around with. Have you seen the programming music with Python, like the Foxdot stuff before?
No, I haven't.
Oh my gosh. Yeah, maybe I'll put a link to it. It's just, there's some really cool stuff people are doing with like live performance music with Python. And so there's just all these really, really great ways that are, very far away from people's jobs.
Yeah.
That lets you play with code instead of, just take your work home with you, which I think that's great.
There was a conference here in Portland over the weekend called Teardown Hardware Conference, and Scott Shawcroft, who is the maintainer of CircuitPython, he did a demo of the Game Boy. He kind of hacked a cartridge to run CircuitPython on an original Game Boy, and his demo was all playing tones, right? So, depending on what bit was set or wasn't set for a particular register, that would vary the length of the tone that was played or the pitch. And the whole time I was thinking, like, I really want you to be a CircuitPython chiptunes, DJ.
Yeah. That's awesome. That sounds like so fun. And doing it on the Game Boy, that's pretty wild, right? Yeah. That's not even intended for it. I feel like the Nintendo stuff is pretty locked down. Cool. So, I guess let's start this conversation with, like, how do I write code in Python and run code? So if I were to go to my Mac and type Python, I'd be running CPython. But when I think of embedded programming, often people say, well, you have to use C to do this, right? But there's a couple of options. Like you mentioned CircuitPython before that, or sort of parallel and started that project as well as MicroPython. And then there's probably other options that I don't know about. Like maybe you could put Python on an Arduino or who knows, something like that. Maybe you talk us through the options and like why you would choose one or another.
Some of the kind of Arduino options, you can just run, straight Python on there.
And that's just CPython that we all know and love?
I believe so, yeah. But the downside is, the devices are a little bit bigger. They're a little bit less lightweight.
Use more battery, probably.
Use more battery, and they're kind of geared towards a more advanced audience.
Okay.
MicroPython, I actually haven't done much work with MicroPython. I don't really have any of the devices that run it, so I don't have a microbit or anything like that. But that was the original Python for kind of these, devices, and CircuitPython forked from it maybe about 3 years ago, and it differentiates itself by aiming to be the fork that's focused towards learning. So it's not,
right,
maybe the fastest or the most optimized, but it's the one that's going to be easiest for beginners to pick up on and use.
And that's important because it can be super frustrating with some of these things. They're kind of glitchy. Like I'd only done mostly web development and server-side programming and stuff for a long time. And recently we did some mobile development for my courses. And man, I just felt like, wow, life is a whole lot harder for some people than others. And I kind of get that sense, like watching you work through all your devices, like they're really cool and they do work, but they all take like a special little setup, or like it's a little tricky to get started, right? Not hard, but like, you got to find the right volume and this one's not connecting and just like that kind of stuff, right?
Yeah. I mess with mine probably more than most. But the goal for these CircuitPython devices is that you plug it in and it shows up as a drive. And if you're not, messing with it like I am or kind of plugging in a bunch at once, it does work relatively well.
Yeah.
There are a ton of guides on Adafruit for a lot of things that you might want to do. And they're also really good about releasing helpful libraries.
Okay, like little Python libraries you can use and stuff?
Yeah, like these LED strips are, in Adafruit land, they're called NeoPixels, but they're just WS2812 LEDs. So they have libraries for filling all the NeoPixels on a particular device, like the Circuit Playground Express has, the built-in ring. So a lot of kind of helper methods for things like that.
That's really cool. This portion of Talk Python to Me is brought to you by Ting. Let me tell you about Ting, a new mobile service available in the US that's targeted at developers and other technically savvy folks. First of all, their average customer only pays $23 a month, but they're no discount provider. Their service runs over T-Mobile's and Sprint's fast nationwide network. If you don't use that much data because you're usually on Wi-Fi, like many of you are, then Ting will save you a ton of cash. But don't worry, you can still use as much data as you like for just $10 per gig. One mobile feature I use all the time is tethering, and with Ting, you get unlimited tethering at the same data rate with your account. $6 a month for a phone line, $10 a gig, $3 a month for text if you usually chat over iMessage or WhatsApp. Think about it, no contracts and super clear and fair billing. Visit python.ting.com, that's python.ting.com, and check out their savings calculator. Enter your usage and see exactly what you'd pay. Use that link and you'll get a $25 credit to try them as well. That's python.ting.com, or just click the link in the show notes. Maybe that's a good place to talk a little bit about some of the devices we might start with. We'll dig into you got a bunch here we're going to talk to. They're going to be really fun.
Yeah.
But, everyone who attended PyCon got a CircuitPython Express. Is that what it's called?
Circuit Playground Express.
Circuit Playground Express.
Yeah.
Yeah. And maybe that gives people a good idea of just what's possible these days, because how would you describe the size of that thing? It's like, 5 centimeters across, 2 inches, something like that. Across probably. About 2 inches. Yeah. And, maybe describe all the stuff that is on this little tiny, super thin device here.
The cool thing about this, I was showing you some of my other projects, like something that I built at a teardown workshop, and it involved a lot of soldering.
Yeah, with hot irons and maybe not connecting the right thing to the right. It's pretty intimidating, actually, if you haven't done it before, I think.
Yeah, it definitely is. And not yesterday. I've gotten a lot better at it, but definitely when I was first starting out, I've gotten like little burns here and there. So you do have to be kind of really careful. You have to think about polarity of things. Am I putting it in the right way? Am I using the right components? Even breadboarding, there's kind of some complication to it. So the thing that I like about these Circuit Playground Express devices, it has kind of everything that you need to just get started conceptually on one board. So it has both inputs and outputs, right? So inputs being things like there's 2 programmable buttons on here. There's a switch that you can program. There are some sensors on here, like there's an accelerometer, there's a temperature sensor, a few other things. And then the outputs are the ring of LEDs around it.
And you probably can connect other stuff. Like, could you connect a speaker or something to it?
So there is a tiny speaker on it.
That's awesome.
And then you can use there's kind of these inputs and outputs along the sides as well that you can connect to, you can hook up a NeoPixel strip or something pretty easily with just alligator clips.
Yeah. So it's like a circle, and there's maybe 10, 12 little punched out rings on the outside, and you can connect stuff and control like lights and stuff with that, right?
There's some inputs in here, both analog and digital.
That's super cool. And that whole thing costs like, what, $25? It's not super expensive, right?
Yeah, I think these are $25, $35.
Yeah. So if you wanted to get started, this is probably a good one because it has a bunch of built-in sensors. You don't have to like try to attach them and so on. That's a pretty good option. Another one that looked interesting, is not really in the realm of what you've been working on, but maybe other people would be interested in, is there's a Pygamer, right? So if you're interested in like doing little games with like Pygame, that's another good option. And it's more, but it's like $20 more. It's not like it's like $49. There's a starter kit for $59. Like, these things are all really approachable for folks, right? And I feel like these types of devices would be really good for kids or people who are getting into programming who don't fit the traditional just plow through the technical bits until like you get there. Like, I feel like so much of traditional programming is taught with like extreme delayed gratification, right? Like, okay, you're going to take a course on programming, and this semester you won't really do anything interesting at all. So you're going to work really hard all semester and come up with nothing. Maybe the end of next course after this, you'll have something that's cool. And like, really, that's how it goes, right? Like, here's how you do a loop. Here's what a variable is. Here's how the memory works. Here's a heap. And all like, you've got to plow through that in order to get to something like where it actually is creative and fun on the other side. Whereas like this kind of stuff, right? 10 lines of Python, plug in a USB to your computer, and you've got cool stuff happening already, right? So I feel like it's a much more approachable, like early win, get into program. Then once you're really into it, you're like, okay, well, how do I do this looping? Because I want to make it cycle or whatever. I think it's a much more natural way to approach learning programming.
I think so as well. Yeah. All the code examples that I used in my keynote, I try to make them be, each one just kind of building on the next. There's just something, magical about holding something in your hand and having it do something, right? That just, like you said, that kind of immediate reward, immediate gratification. And I think whatever we can do in our industry to get, not just kids, but even just, this is fun for adults.
Yeah.
Right?
Yeah. It's super cool.
Just get more people interested.
There's tons of little projects that you could do with this. I mean, if you're into gardening, you could do IoT, like plant monitoring, all kinds of stuff, right? Like it's pretty neat. I love it.
I'm still a hobbyist.
Yeah.
I like that you don't have to be an expert to use a device like this and kind of get the basics down and get the concepts down. I'm not an electrical engineer and I never will be, but I can still do a lot with something like this.
Right. You're not mapping out the actual circuit
right.
or whatever, right? But yeah, that's really cool. And it seems like some super fun projects that we'll talk about. But before we get into the actual steps of programming, let's just maybe talk real quickly about the BBC microbit, because you quoted some cool stats from there at the end of your keynote. I had a topic on it before on the show, and it's a really cool story where the BBC funded giving a little device, kind of like what we're talking about, to what grade was it in all the UK?
Oh, I don't remember.
Like late elementary school, early middle school, something like 5th, 6th, 7th grade, something like this, right?
Yeah, like 11, 12-year-olds.
Yes, exactly. Okay, so there's some really cool stats. If you want to tell us about that.
Something I really like about this project that they did is they did kind of an exit survey, right? So they surveyed kids kind of before and after, and some of the numbers that came out of this were 90% of the kids after they got to use the microbit thought that coding was for everyone.
Right, because a lot of people feel like coding for either super geeky people or super smart people, or maybe the intersection of those people. I don't know, like it doesn't feel like, oh yeah, everyone can just do this, right? It feels very like you got to know the magic, and it's just too hard to get into a lot of times, I feel. Maybe that's a little bit less these days. I mean, when it was like C++ and assembly, it really felt, or Java even, it felt like, this is not something you just walk up to and get a job in, or you become proficient in. Even
kind of when I first got the hardware stuff on my radar, a lot of the projects that are coming out, I wasn't really kind of particularly interested in them, right?
Yeah.
It wasn't until I started seeing, projects and builds and guides and tutorials that were doing things that matched my interest more, matched my aesthetic, that I recognized, that it was something that I could try as well.
Yeah, it's awesome. Like build something you could wear, or like make something awesome for Halloween, right? Something like that. That sounds really fun. Yeah. So another stat, 86% of the kids who went through it said computer science is a topic that's more interesting to them afterwards. Yeah.
Yeah, I think so as well, right? Like you said, kind of mixing those things in little by little, right? Looping control statements, if else, and then seeing it happen.
Yeah, absolutely. The visual aspect. And then I think also just the learning just enough, right? And so I guess we didn't mention this at the top, but it's worth pointing out that the microbit ran MicroPython at the time. Actually, they started out historically trying to do some other way to program it. I don't know if it was like in C or it was in, they were trying to build their own little operating system for it or something, but it wasn't Python and MicroPython until it got a little ways down the road. And they're like, this looks hard. You should use MicroPython. And they went for it. So that's really
awesome.
Good they did. Yeah. And then the last one, you said was very near and dear to your heart.
Yeah. 70% of girls said that they would choose computer science as a subject option after using the microbit.
That is super cool. I think it really speaks to like the first one. Like a lot of people find it more interesting, or they thought it was for everyone. And of course, girls would feel that way as well, right? Like it's a fun thing to work on. And like a lot of these projects we're going to talk about are, super interesting for girls and boys, right? But definitely interesting. So let's talk a little bit about the overall flow of like, what does it look like to program one of these things, right? Like maybe I go and order the CircuitPython Express, Circuit Playground Express, sorry. And I get that, and then, well, now I have this thing and it's cool, but what do I do, right? Like, how do I get started? What are the steps?
These are Arduino compatible. So there is a mode that you can go into where you can just write straight Arduino for this as well.
Okay.
So it's not limited to just CircuitPython. So depending on when and where you bought your Circuit Playground Express. It might either already have CircuitPython loaded up on it, which is great. You'll plug it in and you'll see a CircuitPython drive. If you don't, it's pretty easy. All you need to do is check out the Adafruit website, and there's instructions for putting this into bootloader mode. And you basically just drag and drop a file, and then CircuitPython's available.
Okay, nice.
Yeah. And if you
that's
picked
cool.
yours up at PyCon, CircuitPython's already on there. So easy
Beautiful.
peasy.
Yeah, super easy.
Once it's available as a drive, you will see either a main.py file or a code.py file. I believe code.py is the standard that they're moving towards. The really nice thing about these devices and CircuitPython in general is with Arduino, you would have to write your code, and then there's a compile step, and then there's a step where you'd have to load it onto your device, and sometimes it wouldn't transfer correctly or it wouldn't be recognized. And so there's just kind of a lot of waiting and fiddling in the process. With CircuitPython, all you need to do is, if the code.py file is not there, you make it, you type your code in, you save it, and then it auto reloads on the device.
Yeah, that's cool. So basically the programming effect is I just edit this file, and then when you hit save, it reruns it. Either it's good and it runs, or it's going to crash or whatever. And we'll talk about debugging them in a little bit. But yeah, it basically just auto refreshes. I mean, kind of like Flask or something. If you're doing web development, you make a change, it detects it, and it just goes. But it's just on the device, right?
Yeah.
So you don't have to like turn it on or start Python. You don't have to do any REPL thing. You edit a file, like by virtue of powering it, it's trying to run that file, and then it just watches for changes, I'd guess, something like that.
The important thing here, though, is you do want to use a known good micro USB cable that has both data and charge.
Right.
A lot of cables don't. And so point of frustration for a lot of folks is they're using a cable that's just for charging. The drive isn't being recognized.
Like that $3 one you got at Target or something, right? It's $3 because it probably doesn't carry the data or whatever.
Right.
Yeah. Okay. Yeah. So you got to be real careful about that. But other than that, like you basically plug in a micro USB thing, then regular USB to your computer, and then it's up. You have to find it as a volume or a drive, right? So you got to go and hunt that down.
So on Mac, if you have your Finder open, it'll just show up there on the left-hand side.
Yeah, and that's easy. And it's probably similar than Windows Explorer. It probably just shows up as another like attached drive or something.
I believe so. I don't use a Windows computer. It's ironic, right?
Yeah, don't you work for Microsoft?
I do. Yeah.
You work on this code.py file. I guess maybe it's pretty much straightforward. You import some of the libraries that maybe CircuitPython provides so that you can program things, or maybe something from Adafruit. So like the regular standard library doesn't probably have something for talking to LEDs. Right. But this probably has a bunch of stuff like that you're going to work with.
Some of the libraries are kind of baked in. So on the Circuit Playground Express, there's Circuit Playground Express library that makes it really easy to work with the buttons, for example, and some of the sensors on the device, the switches and all of that. So for that, you just have to import it. Some of the external libraries, like the ones for working with, additional NeoPixel strips, or some of the things that you can, kind of extend and plug into this, need to live in a library folder.
Okay.
And you can just find those dependencies on circuitpython.org.
I see. So if I want to have some sort of external dependency, that's possible?
Yeah.
Yeah. Do I pip install it? Do I download it and copy over? Like what's the mechanism? Like I just copy into this libraries folder?
Yeah, you just copy it into the libraries folder. There's definitely some additional work that can be thought of with packaging. There's no good way of pegging a dependency to a version, for example, but the project is open source, and they will gladly...
PRs are accepted?
Yeah, they'll gladly accept your contributions in this space.
Yeah, I can imagine that they would. Like you said, it's early days, right?
Yeah.
So it's wide open. I feel like it's really growing quite a bit. A lot of interest is developing here, and a lot of different angles, like the education space, people who are makers, all kinds of stuff.
I think the key here is, it's not just for kids. People look at some of these devices and they're like, oh, this will be fun for my 8-year-old, but it'll be really fun for you too. For
sure. You can definitely do some cool things. One of the things that I find is actually a challenge, maybe because I'm good at programming, I don't perceive that as a challenge, but just my assessment of like looking at this space, like what is challenging. The programming is a little challenging, but I feel like knowing what extra things go with my device? Like, what if I want, like strips along the wall that light up when it watches me walk by, or, it just says, it detects me and like, welcomes me when I'm home, or welcome to our house, or whatever it says, right? Like if I wanted to do something like that, like I just look at all the stuff I could go shopping for at Crowdsource or on Adafruit.com, and I'm just like, there's a bunch of stuff here. I'm not sure it's even compatible with this thing I want to get. Like, how do you address those kinds of things?
So I've gotten kind of a lot better about figuring out what parts or components I might need and how things work together. But until that happened, I would just look at guides online that had incorporated some aspect of what I wanted to do. And then I would just kind of deconstruct that and kind of pick and choose and figure out ways to put those things together. So there's guides on Adafruit. There are guides on Instructables. I just met a really cool maker who does a lot of wearable stuff for an Arduino-based magazine, Sophie Wong.
Okay.
Yeah, she makes really cool. She had this LED jacket. She does kind of cosplay. So she brought this helmet, like LED helmet that she made for astronaut costume. That was just amazing and incredible.
Oh, wow. Yeah. I can imagine the cosplay stuff. It's really got a lot of lot of cool options, actually.
You should check out her guides because her LED jacket was powered by one of these Circuit Playground Expresses.
I rode over here on my motorcycle, right? And I just saw yesterday on YouTube this guy who had built a helmet like from Tron. It had these LED lights all over it. It had this like sort of one of these type of chips and batteries on the back, and you could do some like super cool stuff with that as well, like have that light up while you're riding at night, or it's really, there's just a lot of cool little projects you could just take on, right?
My only piece of advice in that space is you want to build things incrementally. So you might have, this kind of crazy idea of, this grand vision, but you'll have a much easier time and you'll end up on a happier path if you start with something much smaller scale and either really understand how all the components work first and how they work together before you take on a really large undertaking. Yeah.
Even on small things, right? Like write one line of code, see it run.
Yes.
Write another line of code, see it run, because there's not a whole lot of debugging or like high-end tools to attach it to analyze it, right? It's kind of like print statements, and we should also talk about that. If I like try to figure out what's going on, I do a print statement or something like that, I'll probably be a little disappointed on the output at first, right? If I don't like find a way to connect to it.
All the code is running on this little device and you won't see any output.
Right. It has no screen, and it's, as far as it's concerned, it's its own operating system. It doesn't care about your Mac or your Windows or whatever you connected it to, or because it might not be connected to anything, right?
If you want to see any debugging output on this, you can either use something like the Mu editor. So that's an editor that's good, not just for beginners, but for folks who are just starting out with hardware, because there's just kind of buttons for all these things. Right. There's one button that says open serial console, and that's where you would go to see your print output. Right.
So it just listens for the serial output and it just prints out whatever it sees, right?
Yeah.
Which is, so these things, when you connect them, they basically appear to your computer like modems. Is that right?
As a drive.
Okay. Yeah. So you connect to them and you get the output and whatnot. That's cool. I guess another, so we talked about the Circuit Playground Express. Another one that's a pretty good one, and that's self-contained, right? So knowing what I need to get for that, I can do a lot of interesting stuff just with that one little thing and a power data cord. There's also PyGamer, which is kind of cool, little screen, a couple buttons and a controller.
There's a Pi badge. I have one right here.
Yeah, the Pi badge is super cool. It's got some buttons and a screen, like 2 sets of buttons, like an A/B button and then like the 4 arrows and a little screen on it. Those are both really cool. And then I don't know about this one. You probably can tell us, but the PyGamer comes with a starter kit as well, with a battery and a speaker and a little box it goes into. So, for me, I'm at the super early stages of this stuff. So I'm like, all right, starter kit. Does it say starter kit? That's good for me. I'm going to try that maybe, and then see what else I got to get.
I believe the PyGamer is going to be in the Ada box that's shipping right now.
Okay.
Yeah. So if you're subscribed, you should get a fun surprise in the mail.
Oh, how cool. How cool. Yeah. Some of these things are hard to get a hold of. They keep selling out. Yeah. So I guess that's a good sign.
Yeah. This thing, the Pi Portal, it's been a pretty hot seller.
Yeah, so let me describe the Pi Portal. So the Pi Portal is this, let's say, 3-inch by 2-inch touchscreen, and it looks basically just like a touchscreen from the front. There's almost no other circuitry you can see. And I guess translation, what is that, like 5 by 7 centimeters? And yeah, it's just a little touchscreen that you can program with CircuitPython, right?
The cool thing about this one, it also has internet connectivity.
Yeah, the internet connectivity is missing from the Playground Express, right?
Yes.
And that would be it's like the one thing, like a little Wi-Fi something. Can you get an adapter to plug into it that works?
I don't know. I haven't thought that one through.
I haven't tried it either. So I guess you got to decide, what am I trying to build? Does it need internet connectivity?
Right.
Right.
Do you want to do something IoT related, right?
Right. If it's IoT, then it probably needs that. This portion of Talk Python to Me is brought to you by Rollbar. Got a question for you. Have you been outsourcing your bug discovery to your users? Have you been making them send you bug reports? You know, there's two problems with that. You can't discover all the bugs this way. And some users don't bother reporting bugs at all. They just leave, sometimes forever. The best software teams practice proactive error monitoring. They detect all the errors in their production apps and services in real time and debug important errors in minutes or hours, sometimes before users even notice. Teams from companies like Twilio, Instacart, and Circle CI use Rollbar to do this. With Rollbar, you get a real-time feed of all the errors so you know exactly what's broken in production. And Rollbar automatically collects all the relevant data and metadata you need to debug the errors so you don't have to sift through logs. If you aren't using Rollbar yet, they have a special offer for you, and it's really awesome. Sign up and install Rollbar at talkpython.fm/Rollbar, and Rollbar will send you a $100 gift card to use at the Open Collective, where you can donate to any of the 900 plus projects listed under the Open Source Collective or to the Women Who Code organization. Get notified of errors in real time and make a difference in open source. Visit talkpython.fm/Rollbar today. I really like the screens here. I mean, the LEDs are cool and they're fun, but you have a lot of flexibility of doing fun stuff. So one of the projects you were showing me earlier before we started talking on the recording is the Python 2 death clock. So
yes.
I talked about, legacy Python and how we're finally moving past Python 2, I think. But a while ago, someone made something, I think it's pythonclock.org or Python, something like this, where it's just the countdown until the end of Python 2.
Yeah.
Right? And so you've got this cool little app that you built on one of these. Yeah. And it is beautiful. Yeah. You want to just tell us about it?
Yeah. So I wanted to make my own desktop Python 2.7 countdown, so I could just keep an eye on it.
Yeah.
Didn't have to have a browser tab open.
You come in the morning, sit down, you're like, oh yeah, it's 190 days now.
Yeah. 190 days, 4 hours, 31 minutes.
Right on.
The fun thing about this is I really wanted to kind of use the touchscreen capability here. And so I wanted my Python 2.7 countdown timer to match my mood.
Okay.
Right. So there's a kind of a bunch of different themes that you can flip through with the left and right side of the touchscreen, light colored background, dark colored background. There's different fonts. So, whatever mood you're kind of feeling like that day, more modern, more abstract. That's the version of the Python 2.7 countdown.
Yeah, that's super cool. So you just touch the screen and it cycles through and it's just constantly counting down the time there. Yeah. So tell us about programming that.
So this was interesting. This is kind of where I bumped into some of the limitations and the quirks of a device like this. So there's no real-time clock on this.
Right. Okay.
So you have to go and fetch the time from the internet.
Because it just doesn't, it's like Groundhog Day for it. It doesn't know what time it is.
Once you kind of unplug it back in, it doesn't know what time it is. And it can kind of keep track of the time for a little bit, but then eventually the clock will start to drift. So you want to fetch the time from the internet.
Refresh it. Okay.
Every once in a while.
Wi-Fi, so it's no big deal.
Yeah. The other thing I haven't really kind of figured out how to do in the longer term, this works just fine on a home network. You provide your SSID and password and just a secrets.py file, but it doesn't really work well with captive portals, So if you're at a conference or something and there's a lot of sign-in steps, haven't quite kind of thought that through. So you do kind of have to, tether your phone or something else. But yeah, all the graphics are kind of lower level. So the backgrounds that you see there, they're all, I believe, 16-bit bitmaps.
Yeah, and you have a video of this that people can look at. So we'll put that in the show notes that people can check it out and watch it going and see what it's like. So that'll be cool.
I'll try to share the repo and then a blog post of kind of explaining all of the code ready by the time.
Yeah, sure. That would be great. So there's some interesting challenges to programming this, right? It's not just like, playing with the terminal or even with like Pygame or Kivy, where you program in some high-end graphics thing like OpenGL or something like that. Like there's not like a graphics card in the traditional sense, right? Like, so even getting text on the screen is it requires not hacks, but it requires like funky techniques, right?
Yeah, you have to port whatever font you want to use into a bitmap font. Yeah, so just kind of a lot of downscaling. I don't remember how much room is on this, but it's enough to kind of get you going for most basic projects, but you can't, drop a uncompressed video on here or something like that. You'll run out of room.
Sure. And you have to do interesting optimizations potentially. Like if you're going to animate the numbers, right?
Yeah.
You maybe have to like pre-allocate all the font representations for 0, 1, 2, 3 and things like this, right?
Yeah, you can kind of optimize by saying, which characters are you going to be using in the course of your program? Load those from the font.
Yeah, so you have to think about some things when you work on these super small devices that maybe we might just overlook, right?
Yeah.
That's pretty cool. But yeah, it looks great, and we'll put the video of it up. It's going to be fun. So maybe you have a whole bunch of hardware, big, small, screens, no screens, lights, no lights, hanging around here. Maybe we could just talk through some of these devices and some of the cool little projects or things you might be doing with them.
Yeah, I can kind of start from smallest and work my way up. So this here is a Trinket M0.
Yeah, so this is maybe a 1/4 inch by 1 inch, something like that. So 2 centimeters by like 1, maybe.
Teeny tiny.
Yeah, very tiny.
Kind of, about the size of a US quarter.
Yep.
And pretty basic as well. And, to be fair, I do have a lot of Adafruit devices here. I'm a fan.
Yeah.
But there are other devices out there that do run Python or, MicroPython or even CircuitPython. But I will kind of talk through what I have in front of me and, what I use for my projects. So this is kind of nice because it does have a micro USB for programming.
Yeah, it's really nice that it just plugs into like, hey, I have a Kindle, so I'm just going to grab that or whatever, right?
Yeah.
Just use that cord. Or I have a certain type of Android phone. Maybe it just takes that.
So there's just like, a handful of inputs and outputs here, and then, mounting holes. So if you're really kind of tight for space, this is a good option.
That's super small.
Yeah, it doesn't have a port, that JST port for something like a LiPoly battery or, different kind of battery enclosures like the Circuit Playground Express has, right? And that kind of plugs in there. So this is micro USB only. And then this right here is the Gemma. Okay.
The Gemma is really like a 1/4 or something like that or so. Yeah.
This is what was included in the PyCon swag bags last year.
Right. The 2018 one. So this was like the dip your toe in the water of the IoT before the Circuit Playground one.
Or programming hardware, because this also doesn't have any internet connectivity on it.
Okay.
The nice thing about this form factor is it's great for SOBO electronics and wearables, right?
Okay.
So it's got these big pads on the sides that you can use to run conductive thread through or conductive paint, right?
This thing is super tiny. It's like really about the size of a 1/4. It may be thinner than a 1/4, except for it's got his little power thing bumping up there.
Right.
You could probably make some really cool Halloween costumes or something for, like a parade.
Yeah.
Or if you're giving a talk, right? Like you've been known to have some pretty cool devices that like you've like secretly worn into the conference talks when you're giving them, right?
I used Gemma M0s for my Python powered earring.
Yeah, that's awesome.
That I'm holding right here. I will turn them on. They're bright because, they're meant for being worn on like a conference stage so that folks can see me in the back.
For sure.
But these are really, really fun.
So they're like it's a big ring of LEDs that are animated, and then like an inner little light thing as well. And then this little tiny circular board that we just talked about is back there with a battery stuck to it.
Yeah.
Doing all the magic to make it actually happen, right?
I did have to do quite a bit of soldering, to get everything to work here. There's 3 layers of LED rings. So the kind of these, individual NeoPixel rings. And you'll see that each one of these has pads on the back here, a data in, data out, a ground, and a power.
And did you have to solder these?
Yes.
Okay.
You can see they're kind of small and unwieldy. So it was a fun little project, but something a little bit more complicated than, a Circuit Playground Express, for example.
It requires actual hardware aspects of like building hardware a little bit, right? Like you've got to connect stuff and whatnot rather than just like pure programming to the thing.
Just some soldering skills. This project was based on a guide by a really cool maker. Her name is Becky Stern.
Okay.
And so her original idea was, having this Gemma with kind of one LED ring and I wanted to have more LEDs, because I just always want to have more LEDs. So I added more in there and then wrote my own custom Python code.
Yeah, that's really cool. Another one that you were showing me that I thought is pretty cool was with the Pi badge.
Mm-hmm.
So with the Pi badge, I'll have to describe it a little bit. It's got a little screen. The screen is maybe 1.5 by 1 inches, maybe a tiny bit larger than that. And it does have buttons and stuff, but it's meant to be worn as an actual badge at a conference, right?
Yeah.
Like instead of like just the printed one or whatever.
Yeah, it's what I'm wearing in my Twitter profile picture.
Okay, really cool. And so you obviously have the screen to put like your name, hello, my name is Michael or Nina, or whatever you want to put there. But you could also do other stuff. And at PyCon we have this like certain color of badge means I'm willing to be in photos or I'm not willing to be in photos. There's a couple of other things you can get, like stickers, little like cloth ribbons that go under that indicate a few things. But you had this really cool idea of taking a NeoPixel lanyard, the actual like rope thing that this hangs on, and lighting that up based on how you're feeling now or how you want interactions right now, rather than blanket, I don't want pictures, or blanket, I want to talk to people or I don't. But like right now I'm busy, please don't talk to me, or hey, I'd love to talk to you, come on over, right? So tell people about this project. This is cool.
So the nice thing about this Pi badge, it does have, kind of mounting holes, but then you can also use them for just a clip.
Right.
So
lanyard,
you can easily wear it around your neck. And my coworker, Tommy, I hope I pronounce his last name right, Tommy Falgau, he did this really cool build of a Lego badge holder with kind of this Arduino-based LED badge lanyard. It just looks awesome. I'll send you a link on Twitter for you to share with your listeners. And I saw it, and he kind of did some IoT stuff, and he wants to make it internet connected. But, the Pi badge is not internet connected. And so I thought, how could I make this fun and useful just as a wearable? And I think I would label myself as an expovert, at conferences.
Yeah. Describe that to us.
I think a lot of people who know me casually would find it hard to believe that I'm very introverted. And so I do like meeting people. I love talking to people, but at some point I need to kind of just, run away and recharge and have quiet time, or I slowly kind of get crankier and crankier.
I've seen you at conferences, and it's like there's always a crowd of people talking to you. So it's wonderful, but it also is draining, right? Like, I mean, when I go to PyCon, by the third day, I literally have lost my voice because while I love talking to people, I just, at some point, like my body breaks down and just says, no, it's not, you're not taking any more of this, right?
It's so cool. I love that people want to come and chat with me, and I never want to be rude or turn someone away. So there's always this conflict of, I need to do some self-care, right?
Right. Or just, I got to be ready for a meeting or presentation in 15 minutes. Right. Like I was at the booth at PyCon getting ready to do a live presentation. So I was sitting kind of next to this little pop-up stage in the expo area. And I was like literally trying to get the demos ready. And someone's like, oh, Michael, I'd love to meet you. Hey, I was going like, hey, it's really great to meet you, but I really need like 5 minutes because I think we were doing a live Python Bytes recording. I'm like, I really have to figure out what we're talking about in 5 minutes, right?
Yeah.
So there's just times like that at conferences where it's like, just you would love to be able to like signal that.
Yeah.
So Pi badge.
I'm going to use the Pi badge for that, and an LED strip. And there are, I don't want to say proprietary, they're not proprietary, but there are some kind of data out ports on here. They use a 3-pin 20 millimeter JST clip. So you just kind of have to find and buy the right one.
Right. It's not like you just plug in micro USB or something, right?
I have a few here. I saw Scott Shawcraft, the CircuitPython maintainer. He, works with Adafruit. I saw him in Seattle early last week, and I was like, please bring me some of this, odd looking adapter. So it kind of looks like these, we'll talk about powering your projects a little bit later. It kind of looks like these LiPoly, JST connectors. There's just one more pin.
Right. These little white 3-pin connectors. Yeah.
So the battery just has 2, red and black, ground and power. This has 3 because there's a ground and power and also data.
Okay.
So you can just plug one of these right into the Pi badge, And then I'm going to do a little bit of light soldering and just solder my LED strip to the end of this, which means, I can easily disconnect it. There's not a lot of wiring or anything like that. And that's just going to run through lanyard clip.
Yeah. And then this connects to the NeoPixels?
Yep. That's going to connect to the NeoPixels. And so I'm going to be able to kind of adjust and say, instead of do I want my photo taken or not, it's like, well, maybe if my badge lanyard is red, I can also, update the message on the Pi badge here saying like, now's really not a good time to talk. Maybe yellow is like only if you really need to. And then if my lanyard green, come up and chat, I'm happy to.
Right. Or it's rainbow colors and blinking or who knows. Yeah. Well, just something obvious. And I think that's super cool. So the lanyard, it basically is like a ring or like a strip of like super bright LEDs, right? So like not just the little badge will light up, like your whole lanyard will like actually have colors and communication. That's cool.
I'm so grateful to Tommy for this idea. And he's actually going to be productizing his version of the LED lanyard badges so that you'll be able to just go and buy a kit from him.
Yeah. Cool.
Yeah, I think so as well. I'll probably be documenting my build on this and trying to, I'm so bad about, I like getting in the zone and building these things, and I'm really bad about stopping to take pictures and then document.
Right. Because along the way, you almost got to rebuild it a second time.
Yeah.
And just document it the second time through.
But I will share a link with his tweet and his product. I think it's going to make conferences a lot more fun. But these are just the same kind of individually addressable LEDs that are on the surface of the Circuit Playground Express. They're just kind of in a strip form.
Yeah. This looks super cool.
And this project is going to involve a little bit of sewing so that I can get my badge clip on there.
I love it. I would love to see it. I mean, it's going to be a little bit tricky just in terms of like getting conferences to offer it because it'll cost some money, right?
Yeah.
It won't be as cheap as just the paper, but if they could do it, it would be so cool, right?
Yeah, I would love to see that at some point in the future.
I mean, they did give them out in the swag bags, the Playground Circuit Expresses.
Yeah.
Circuit Playground Express. It could just be, well, it's not in your bag. It is your lanyard. Yeah. Right? And it has a little screen. So it's not really that big of a stretch, I guess, on that regard.
No. The current iteration, it is a little fragile, so you have to treat it carefully, right? Or, these strips, especially ones that don't have any casing on them, they're pretty bendy here. And so if you break, you'll see in between each strip, there's, the powered data in the ground. So if this breaks or disconnects, then you lose connectivity to the rest of the strip.
It's like Christmas lights.
Yeah, kind of. It's also, I've been thinking through some ways of wearing it, but I haven't figured out a way to make the length adjustable, without damaging the components inside. So
there are some challenges. Maybe it's not all strip, right? Maybe there's just like two parts that light up or something, and there's like just a gap. I'm sure you'll figure it out.
Yeah, that could work. That's always kind of the fun thing about, the prototype or the first build is like, how do all the pieces fit together? Yeah. Despite your best intentions, things don't always fit or look or work the way that you expect them to or would like them to.
It's a really cool idea, and it's one of these sort of practical things, and it definitely fits in with the style of stuff that you're doing. So I think it would be cool. So I guess, we have the bag stuffing volunteers at the conference. Now there'll be the lanyard building and programming thing that's the day before, right?
I bet those volunteers are not too thrilled by that idea.
No, that's got to be a lot of work, right?
Mm-hmm. Yeah.
Cool. All right. Well, you got a few other things. You want to just quickly maybe tell us about those?
So we talked about the Circuit Playground Express. I think the only thing I haven't shown you so far is this.
So this one you got from this recent conference you were just at, the Teardown.
I built this at a soldering workshop. And so this is a custom board. It's designed by Thomas Hudson. He's local to Portland. He works for OMSI. So he does kind of a lot of electrical work for them.
OMSI is a really cool like industrial and science museum here in town.
I'll share a link to his GitHub here. It's actually on the back of the board.
Oh, how cool. The GitHub is on the board. I love it. Yeah. That's really cool. And this comes from, it has a crowd supply on it. And I don't know much about crowd supply, although I've just recently seen a few things here. And it seems like there's a ton of this kind of stuff available. What is that place? Do you know?
It's kind of like a Kickstarter, but for hardware.
It's like, Kickstarter is specifically focused on these types of things. There's some really cool stuff there. Okay, so
I believe Crowd Supply sponsored this workshop, which is what allowed us to walk away with these boards.
sure.
So we just kind of started out with the boards here, and then all of the components, I hand soldered on in this workshop, which was pretty fun. But this is based on the NRF 52840 reference board.
Okay.
So this is something that Thomas designed, and it has Bluetooth connectivity on here.
A couple LEDs, a couple buttons.
LEDs, a few buttons. And he put a bunch of kind of examples online on his GitHub as well. So this is going to be kind of an interesting reference board. And, it shows you that if you have the skills and the knowledge, you can build your own devices that run CircuitPython.
That's really cool. So there's probably a whole ecosystem and set of tooling around actually designing the boards, like if you want to have a board created, right?
This is not in my realm yet. It is something I'd like to learn this year.
It's super cool. It may never be in my realm, but I admire it. I'm sure it's really cool. One thing I do want to come back to before we run out of time, though, is we talked about the serial stuff with print, the Mu editor, but there was another tip that you gave about actually getting a REPL for the Python running on these embedded devices. So maybe tell people real quick about that.
I think Mu is a great project. I personally don't use it. I tend to write all my code in VS Code. I really like the Python extension day to day. So I'll just have a side-by-side terminal open there. I'll use Screen to connect to the serial console.
And that you can get the print statements there instead of using Mu.
You can see the print statements there. And then if you press, I don't remember if it's Control C or Control D, there's a nice kind of helpful hint when you start your REPL. If you hit one of those keyboard combinations in your serial console, you'll just get kicked into a REPL that's running on this device.
Yeah, that's really cool. So you kind of cancel out of it and it just drops you into the REPL a little bit. Yeah.
And you can kind of run stuff, test stuff out. The nice thing about the Pi portal or the Pi badge that has the screen on there is your REPL will be displayed on the screen.
That's super cool. I love it.
I can show you a little demo of that. But Scott, who I've mentioned a few times, he has one of those IBM, I don't remember the model, but those like really clacky old school IBM keyboards.
Yeah, the mechanical ones. Yeah, they're probably beige.
It's the beigest. So he has one of these Pi portals just stuck onto a keyboard, and you can like type in the REPL on this really old school IBM keyboard.
Oh, wow. That's crazy. It probably just has serial input or something straight into it, whatever the keyboard does.
He brought that whole contraption to Pi Cascades.
Okay. Yeah. How cool. That's awesome. And you also had some advice on how to exit out of screen. There's a funny joke. I feel like some of these things are a little tricky. So if you want to generate a random string, obviously there's ways to do it in Python, but another way is to put a first-year computer science student in front of Vim and ask them to quit, save, and exit. Right. I feel like Screen's a little bit like that. Like there's a series of combinations you got to hit just right, and it'll like let you out of it and stuff like that.
The important thing about Screen is you have to press Control A, which is kind of the leader key, and then to quit, you press K. K for kill.
Cool. So let's touch on a couple other things really quick. So we talked all about CircuitPython and programming in Python, and people like Python, but maybe they're using this in an educational context or with younger kids or just people who are not programmers yet. So there's also a thing called Microsoft MakeCode. That's pretty cool. You want to tell people about that?
The nice thing about MakeCode is there's just this online-based emulator. So you don't even have to have access to a device.
Actually, that's maybe the coolest part of it, right? Is that, it comes with a Circuit Playground Express emulator. So you can play around a little bit and decide is this for me? Is this interesting? Then you order the $25 little thing.
It's a kind of a block-based editor, like a Scratch-like editor. So really good for kids, really good for conceptualizing. They've done a lot of really interesting partnerships with Cartoon Network, for example. So there's a lot of, Steven Universe is a really cute cartoon, not just for kids. Personally, I love it. I watch the whole series. And so there's a lot of Steven Universe projects that you can build on MakeCode. And then the code that you generate, it's portable. So if you do have a device, you can run it on there. If you don't, you can run it in the emulator. You can also export it as JavaScript.
Okay.
And in the future,
JavaScript, huh?
Maybe even Python.
Maybe. That'd be awesome.
Maybe.
Okay. No commitment there, but maybe. That'd be awesome. Yeah, I do think it's really awesome that it comes with an emulator. Can you get like CircuitPython running on the emulator? Do you know? Like if you don't have a device and all the stuff we talked about, could you make that happen on the emulator that comes with MakeCode?
I don't believe so.
Okay. maybe someday. But yeah, it's pretty, if it outputs Python, that's kind of good enough. Eventually, if it ever does, right?
There is a group of interns working in Vancouver for the Microsoft Garage program that are doing some really interesting things with CircuitPython and VS Code.
That sounds really fun. What is Microsoft Garage?
So it's kind of like a hack space, right?
Right, like a makerspace type of thing.
Makerspace, yeah.
Okay.
So they have access to, electronics and devices and, kind of the stuff that you would find in a typical makerspace. And they're particularly focusing on the Circuit Playground Express. So I'm really interested in seeing their project.
Oh, that's super cool. Super cool. So I get the sense from sitting here with you with all these cool things like, oh, I got one of these and I tried this here and I got this cable and, oh, have you seen this LED strip? How much fun this is, but also how it would be much better to have that experience with other people who have these things. If you want to get into it, it probably makes a lot of sense to go to like meetups or makerspaces or other things like that where people are doing these kinds of things. What advice do you have for people to like find other people doing this? Yeah,
so Meetup is a great resource. If I lived in Seattle, I'd be going to Hardware Happy Hour.
Okay.
Scott comes with some of his projects. The wearables maker I was telling you about from Teardown, Sophie Wong, she attends as well. That seems like an incredible community. Just at Teardown, for the first time, I went to Control H Makerspace here in Portland.
I haven't been to that one.
Just the friendliest group of folks, really nice space. They have cool hardware. You can talk about joining, but, Meetup, local makerspaces, I think they're both fantastic avenues for getting in touch with some folks who not only have these devices, but are open and willing to share. The lucky thing is, if you live somewhere remote, you really don't need these resources. The guides online, there are tons of YouTube videos.
All right, yeah, the YouTube videos. I suspect YouTube is pretty good.
I keep meaning to make my own, so maybe one of these days that'll happen. But, I do kind of have a lot of devices and a lot of toys, but I didn't, go out and buy these things all at once, kind of worked my way up to it.
Yeah, that makes a lot of sense to start that way. I guess you could always, if you live in a place that doesn't have a meetup port, you could start your own, right? Like meetup.com is free and easy to use. Or even just create a virtual one, right? Like there's some virtual meetups, that would be pretty cool as well. So yeah, it just seems like this is the kind of stuff that's more fun when shared. You kind of discover like, oh, you use that kind of connector and you used it this way. That's really cool. I'm going to try that, right?
I think so as well. Adafruit has got online show and tell that's remote, live stream sort of thing. So I haven't joined yet, but I keep meaning to.
Yeah. That sounds like a real fun one. All right. I guess we should wrap things up with a hashtag.
My coworker, Lena Hall, she's in the big data space. She gave me this idea for my PyCon US keynote. She told me to find a hashtag that hadn't been used yet.
You found a good one.
I found a good one. So it's hashtag Python hardware. So if you are interested in what the Python community is doing with hardware, if you want to share your own projects, if you want to talk about people that you're learning from or people that you're teaching, check out Python Hardware on Twitter. I've seen some activity after PyCon. So we had a flurry of posts and it did kind of drop down a little bit, but I really want to keep the hashtag going.
Yeah, let's keep it alive. And we'll obviously podcast listeners out there can use it and share little videos, pictures of what they're working on, their projects, their GitHub, whatever, right? Like that'd be great to like bring that together.
Please do. Whenever I'm having a bad day, I'll go and look at that hashtag and be like, how can I be frowning right now when, there are all these excited people doing these cool things with Python?
Inspired from your talk, right?
Oh.
Not just your talk, but...
Now I'm blushing.
No, it was a good talk. And I'll actually link to your PyCon keynote as well. It has a lot of the pictures of what you're talking about here.
Mm-hmm.
I'll try to post some pictures as well that we'll link to some of the show notes around it. But yeah, Nina, this is really fun. Thanks for sharing all the stuff that you've been up to.
Yeah, thanks for having me.
You bet. Now, before you get to go, 2 quick questions. I kind of know the answer to this first one after watching you work, but if you're going to write some code, what editor do you use?
I'm a fan of VS Code, especially for this workflow in particular. Something that, folks don't know is these devices are trustworthy, but you don't want to have the only copy of your code loaded on here. So you do want to have a copy locally, preferably version controlled in Git or in GitHub. And so the nice thing about using VS Code for this type of programming is I'll have a workspace, right? So one of my workspace folders, to back up a little bit, a workspace kind of allows you to organize different folders just kind of in one common area and work across them as one project.
Even if they're not within the same parent or something.
Yeah. which is really great. So I'll have my, CircuitPython folder, which is nice if the device is plugged in there, but I'll also have my local folder in that same workspace. And that's the one that's version controlled and everything. And if you have multiple devices plugged in at once, that's also very nice. My original editor that I loved was Emacs. And so I use VS Code with Emacs key bindings.
All right. Yeah, that sounds really good. And you just copy the file over to code.py whenever you want to run that code. That's great. And then notable PyPI package or other library, I guess, you can use in this case, like stuff that's cool that helps you, maybe do some CircuitPython.
There's no PyPI package that I'm thinking of, but one of the awesome Adafruit employees, her name is Katney. She writes a lot of guides. So she wrote a lot of the code and reference material that was on your Circuit Playground Express at PyCon. So I would say check out her repositories for just really good ideas for how to get started with a lot of these things. And then the next is kind of a call to action for Brian Oken, because he was having a chat with Scott about the future of testing on CircuitPython. So maybe like
a PyTest extension, maybe, Brian.
Maybe, yeah.
The gauntlet's been thrown down, so now he's got to do it.
Yes, Brian. Please do.
Perfect. All right, so people want to get involved in CircuitPython and embedded Python, all this stuff. Where should they go? What should they do? Like, what should you leave them with?
Yeah, so CircuitPython.org is a great resource for kind of downloading stuff, getting started. GitHub.com/Adafruit/CircuitPython for the repo. There's also a Discord that's full of really friendly folks. And the community, just like with Python, is what makes this really, really special. So get involved if you can.
Awesome. Well, thanks again, Nina. It was great to talk to you.
Thanks for having me on the show.
You bet. Bye. This has been another episode of Talk Python to Me. Our guest on this episode was Nina Zakharenko, and it's been brought to you by Ting and Rollbar. Ting is the fast mobile network custom built for technical folks. Use their savings calculator to see exactly what you'd pay. Visit python.ting.com to get a $25 credit and get started without a contract. Rollbar takes the pain out of errors. They give you the context and insight you need to quickly locate and fix errors that might have gone unnoticed, until users complain, of course. Track a ridiculous number of errors for free as Talk Python to Me listeners at talkpython.fm/rollbar. Want to level up your Python? If you're just getting started, try my Python Jumpstart by Building 10 Apps course. Or if you're looking for something more advanced, check out our new async course that digs into all the different types of async programming you can do in Python. And of course, if you're interested in more than one of these, be sure to check out our Everything Bundle. It's like a subscription that never expires. Be sure to subscribe to the show. Open your favorite podcatcher and search for Python. We should be right at the top. You can also find the iTunes feed at /iTunes, the Google Play feed at /Play, and the direct RSS feed at /RSS on talkpython.fm. This is your host, Michael Kennedy. Thanks so much for listening. I really appreciate it. Now get out there and write some Python code.